as you transition into your actual lab dealing with locating the epicenter, I want to make one thing about this graph perfectly clear that I did not before. This shows the actual travel times of the earthquake, which means if I wanted to calculate when the earthquake originated from, you take this travel time right here and you subtract that from when it arrived. So arrival time is different than travel time because arrival time is when the seismic station recorded it. However, those P and S waves oscillated way before then. If you want to calculate how long they spent, you can just use this. Obviously, since S waves travel after P waves, it makes sense that their travel time is greater than P waves. So just that'll help you with this lab. So I think I'm going to do map 1 and map 3, part A, and you can do the rest on your own if you so choose to. All right, so seismic station A says that the P wave arrival time is 10 a.m. with some 10 seconds over here. S waves, 10 minute or 10 a.m., 10:02 a.m., my bad. The lag time is just the difference between those, which looks to be about 1 minute and 50 seconds. So I'm going to denote that. 1 minute and 50 seconds. The epicenter distance can be found by, well, we're probably going to use this graph that tracks the difference in arrival times, which happens to be 1 minute 50. Lag time is the same thing as difference in arrival times. So I'll make a note of that right there. Okay, so 1 minute and 50 is the difference, which is about here. I think we did this before. Go to the graph, go down. It's roughly 1,000 kilometers. So your epicenter distance is 1,000 kilometers. The P wave travel time. Well, we're going to need this graph. And we use this graph to find the distance to the epicenter, which is 1,000. And we're going to use that 1,000 on the x-axis as we plot the epicenter distance in thousands of kilometers. So how many thousands of kilometers do we have? We have 1. So we're going to go to 1, and we're going to denote that the P waves traveled this much, and the S waves traveled this much, which looks to be about 2 something, I would guess. Almost 220, but not quite. I would guess 215. I think the key does 210, but I'll be more precise and do 215. So 215 minutes, and the S waves looks like it's all the way to 4. Now, the origin time is the time at which the earthquake originated from. And basically what you do is you take the travel time of your P waves and you subtract that off from when it arrived. P waves arrive first, and if you track the arrival time and you subtract off the travel time, you'll get the origin of the earthquake. So you take 10 minus 215, which looks to be about 950. 745. Is that right? That would be about 1010, but I forgot this 10 right here. Sorry about that. So that would be I can't think today. That'd be 55. Because if you take this and add on the origin time for the time it took the P waves to travel, that would get you to 10 a.m. with some 10-second marks. I'll do B and C just for your benefit. Okay, this is 10:04:20 a.m. S waves arrived at 10:07:40, so the difference would be 2 minutes. No, it wouldn't. It'd be 3 minutes and 20 seconds. I don't know where my brain is today. 3 minutes and 20 seconds. The epicenter distance, we're going to use this graph. If it's 3 minutes and 20 seconds for the lag time, that would get us to 2,000. So plot 2,000 kilometers. Then you go over to graph number 2, plot 2,000 on here, and note the P and S start times. Okay, for P waves, it looks like that it traveled 4 minutes. S waves looks like 7 minutes and 20 seconds. But you only need the P waves, and you subtract that off from the P wave arrival time. So 4 minutes off 10:04:20 would just be 10 o'clock and 20 seconds. Okay, C is the last one I'm doing. 10:06:40, 10:11, that's going to be 4:20. I know that all of you are laughing at me struggling at math. Epicenter distance, so take 4:20. That looks to be 2,800 kilometers. Okay, the P wave travel time for 2.8, that's 2, 4, 6, 8. So here and here. Okay, this looks like it's tracing back to about 520. S waves look like they are tracking back to about, oh, we can call that 940 or 935 or whatever. It really doesn't matter because you're not using that. Okay, so you take this and you subtract it off from when the P waves first arrived, and that gets you 10:01:20. If I made a math error, please note that in the comments. Thanks. All right, as for these two questions, you don't need to know about describing the location of the epicenter. It's just looking for a town name, and you don't understand plate boundaries, so you don't have any knowledge of like the Nazca or the South American or the African plate, so this question is moot. Let's go over to the back, where you actually have a seismogram. Remember, a seismogram is the written version that a seismograph produces. So right here, it's a little easier. They denote P and S like solidly right there. So the P wave arrival time is going to be 9:04. That's when the seismic station recorded it. So 9:04. S waves arrived, somewhere between them. So 5 and 6, there are 3 boundaries. Each boundary, or each mark is 20 seconds. That's 20, 40. I would guess 45 seconds. That little distance looks like 5 seconds. So that would be 45, 9:05, 45, which means the lag time, or the difference, is 1 minute and 45 seconds. Okay, well, go over to this diagram. I'm going to erase some of this. So we have 1 minute and 45 seconds. 20, 40. It's hugging 40. Okay, and then we can estimate that it's about 1,000. Which we then go over to this graph. We already kind of did 1,000, and you just do the same thing for P wave travel time for the S waves. You take this and you subtract it from this to get your origin time. All right, so that is everything that you need to know in order to get some help with that lab. You are more than welcome to complete it, and I'm more than happy to check it. In the next video, I'm hoping to describe the intensity of earthquakes. Hope to see you there.